this lab is about, as the name suggests, is about correlation. So correlation is a powerful mathematical tool, as we're going to see what it corresponds to. And the application we're going to be focusing is acoustic gunshot detection and localization, which is something that we at LUMS and our research group has been involved with for the past in the past. And before I begin, can anybody just point to me? I mean, what comes to mind? I mean, when I say the word correlation, I mean, what's the first thing that comes to your mind? Ji, Rafe, what is the first thing that comes to mind when I say correlation?
Sir, like a relation between like two things. I mean, two things correlate with each other, like something like that.
I'm sorry, so I couldn't hear you properly. I think this thing. So Isra, go ahead.
Yes, sir. What I think is correlation is how two variables or things are interconnected with each other.
Right, excellent. And I think Rafe probably, from what I could hear, was saying something similar. Isra, go ahead.
Yeah, sir, that's it. Correlation.
Correlation.
Interconnected,
right?
Two things interconnected with each other.
Right. So just like your hard work is correlated with the amount of success, right? So there's a linkage between the two variables. Similarly, we can define something called the correlation, and we're going to exactly define what it is for signals as well, right? So there's something which is applicable to signals. Before I begin, let me work with some motivation prompts. Okay. Yeah. So this is a YouTube video, which you're going to be able to see online. So let me just play it out. So this is a company in the US, which is called ShotSpotter. And let's just play this video out, okay?
A gun is fired somewhere in your city. So what happens now? In the past, there was a slim chance the shooting would be reported to police at all. Even when it was, it took precious time, and there was often confusion regarding the location of the shooting and other pertinent information. At least, that's how things were. ShotSpotter has changed all that. By utilizing advanced technology honed over 2 decades, we have automated the process. We monitor gunfire activity 24/7. So if a gun is fired in any area within ShotSpotter coverage, the system detects, locates, and immediately alerts police of the gunshot. So how does it work? It starts with acoustic sensors that are placed on buildings or lampposts throughout a neighborhood. If a gun is fired anywhere in the area, multiple sensors detect and timestamp the sound. The precise location of the gunshot is determined based on the amount of time it takes for the sound of the gunshot to travel to each individual sensor, effectively triangulating the sound. The exact location of the detected gunshot is indicated by a dot on a map. Once an alert is generated, it is immediately sent to our IRC, or Incident Review Center, where trained acoustic experts then analyze each incident in mere seconds, determining if the sound is gunfire. ShotSpotter acoustic analysts receive extensive training on reviewing and classifying gunfire by distinguishing gunshots from other impulsive sounds that are not gunshots. In addition, they are trained to append additional contextual information, such as multiple shooter alerts or full automatic weapons alerts, that can prove to be essential tactical intelligence for law enforcement agencies responding to these crimes. The entire transaction takes place in less than 60 seconds. With the real-time ShotSpotter alerts, police can immediately be dispatched to the scene. Utilizing the gunfire audio clip and tactical information, officers can approach an exact location quickly and safely to engage the shooter, interview witnesses, and collect key evidence at the crime scene. ShotSpotter's Respond app enables patrol officers to receive real-time alerts quickly and effectively in their patrol car, on MDTs, or on the go on their smartphones. The ShotSpotter alert system is used in more than 90 cities and is an invaluable tool to help make communities safer by responding to gunshot incidents faster, making it easy to find evidence and reducing risk for police officers.
All right, so once again, so this is actually a system that is in place in many cities across the US, and primarily for law enforcement agencies in an urban environment, right? And so I was really intrigued by some of the comments by Hussein, for example, who said this would go berserk near a battlefield. You may be able to view this online, so they're publicly available. So there are systems that actually are used in the battlefield by the US and the British military to exactly do this. So in order to locate sniper fire, right? So there's systems available with them, right? So you Wikipedia this, and you'll be able to find them, all right? So, but what for our purposes, I mean, what we're looking at is how you're using signals or how you're using technology to be able to develop an automated system that can not only detect that whether there was a gunshot fired or not, but it can also try to localize the exact position from which it was fired. So, right, so this system, as what the claim is, that they can localize the shooter within an urban environment, exactly pinpoint where the shooting came from. And these are some of the ideas that we're going to be looking at, right? So some of the objectives, the tech objectives for any system that you would develop would be, if you're recording anything, you would need to first of all identify with the computer program whether this really is a gunshot or whether it was a clap, right? So they might seem similar to a computer algorithm, right? And more important, and as well as one of the other objectives would be, where was it fired from, okay? So these are the two objectives here, right? And we have worked with these kind of systems in the past. And this system that you see here is probably around 2011 or 2010. And some of the audio recordings that you're going to be working with in the lab tasks have actually been recorded with this particular system that you see on your screen, with actual gunshots in a firing outdoor firing range in Lahore, right? So we've used this system to record them to be able to build our own detection systems, right? We've done many other works. So there was this another system that we developed. This was a senior year design project, right? So where this was now not inside a computer, but rather a microcontroller or an embedded processor in an embedded form, in a small form, and which could localize impulsive acoustic events. And this also earned I think the second prize in a regional IEEE project competition back in 2013, I believe, right? And then we also did some experiments. These are not actual guns. These are toy guns, the patakhe hote hain, right? And we did these experiments all across LUMS, trying to figure out what effect does the buildings have on the recording. So they're going to be reverberations, or reverberations is something that they've already done in lab 3, right? So you because of those multiple paths that sound has to travel at, the gunshot is going to experience, or the audio of the gunshot is going to experience something called reverberations. And now it is the job of the computer algorithm to be able to identify the gunshot signatures, even though it experiences reverberations, right? So that's another time. So that's something we worked on. And perhaps thankfully for you, we're not going to have you work on this in the lab task. So we're going to have some simple lab tasks for you using some audio recorded data with actual gunshots. Another motivating problem to motivate why correlation is beneficial is COVID-19 reporting of data, right? So आप जो है COVID-19 के दौरान जो है, everybody is more or less following the daily statistics that come out, right? And a common theme that I have noticed amongst people is even if there's a surge in cases in a particular day from before, and the number of deaths have not really increased by that much, I mean, they sort of take solace in that fact, right? So they sort of take comfort saying कि अच्छा चलो यार cases तो बढ़ गए, लेकिन deaths only increase हुई, without really realizing what? जी दानियाल? I mean, is that assumption correct, or is that comfort level correct? All right. So Omar types out the answer, and Hania says no as well, right? So the increase in deaths come after the case. So there's a certain delay from the surge in the number of reported cases and the surge in the number of deaths, right? And then you would be interested in finding out what is that exactly, what that delay is, and we will use correlation as a tool for measuring that lag time, right? And this is, if you go on WHO documents, or World Health Organization, I think they call it the average lag time from reporting to death, right? Okay, so here, these are the motivating problems. So what is the potential tool for this? The potential tool for this is correlation, right? What is correlation? Let's just briefly talk about that, right? So, and before I go there, I will just give you a quick review of signals in MATLAB, right? So this, what you see on your screen is an actual gunshot signals, and it's a gunshot template that we have actually extracted from the recordings that we made ourselves, right? So this is a specific format where it goes down in pressure and then goes up and then comes back again and settles down to zero. Okay, so this is what you would use, something called the gunshot template. And this visualization is a function of continuous time in seconds, right? However, when you're dealing with MATLAB is just, the signal is just an array, right? So the x-axis is actually the array index. And more specifically or more correctly, that signal can be visualized, would rather be visualized as a stem plot, right? So you have not a continuous signal, but rather a discrete signal, which has this many samples, a sample here, one sample here, one sample here, and every one of these indices, right? So the point here is that signals in MATLAB are all arrays, right? And we're going to be working with, when we say we're going to work with signals in MATLAB, what that means is that we're working with arrays in MATLAB, essentially, right? So the mathematical notation that I'm going to use from here on, and what we've used earlier as well, is that the signal is represented by x of n, and this x of n is really the vector notation that you would have been familiar with already in an array. What this means is here there's a vector x, or there's an array x, and this number x of n corresponds to, or this notation corresponds to the nth, the element lying at the nth index of the vector x. Okay? So this is a notation that we're going to we're going to use, and this is something we need to be familiar with as we move on. Okay? So just as an example, this is some vector x as a toy example here, and what that means is that the first element is 0.15. So I would say x of 1 is 0.15, x of 2 is 1.21, x of 4 is 0.81, and 5 is 0.26, and so on and so forth, right? So this really is the index. Isa, do you have a question, or was this hand raised from before?
Sir, I'm so sorry. I forgot to
No
lower
issues.
my hand.
No issues. All right. So this is what signals are in MATLAB. Okay. Now let me just quickly go through some review material, right? So if I ask you, so this should not be here, I can tell you nevertheless. So if I ask you to compute the average value or the sum of the signal, I mean, how do you implement this in MATLAB? Can anybody guide me here or help me here? Qasim? I mean, you're the only person I see the video of, so I'm sorry, I'm picking up on you.
Sir, I don't know.
You don't know, right? So if you, all right, sum command, excellent, right? So the sum function, Aisha, excellent, Hussein, nice.
Sum command or for loop लगाएंगे बीच में हम.
Excellent. So who was this? Who said something about the for loop?
Me.
Can you?
Yeah.
I don't see your name. आप अपना नाम बता दीजिए, please, so I can.
Mohammed Haris Saad.
Saad. Right, Saad. So you can
Haris.
Yes, you Haris.
Mohammed Haris Saad. Yeah.
Haris. So you can use a for loop for this, but I would rather you not. Right. So the first option that you mentioned is actually better as far as MATLAB is concerned. Right. So you just use a sum command. Right. Sum. And you just divide by the length of x, right? So this sum of x, all this does is it just sums each and every one of the variables, or each and every one of the elements inside the x vector, and then it divides by the length of x, where L is by default, by notation, the length of x. Okay? So Hanya, maybe you can approach someone of the TAs. If somebody can type in the sample code, the TAs, to help Hanya here. How do you use? Okay, excellent. So, but Isha or Hassan, if you can do that as well, all right? So let me give you another here. So this is a sum of the squares now. Okay? So Hanya, I may also pick on you because your name is the same as my daughter's. So please, if you can unmute yourself.
First, we would calculate the sum of the square of x.
Yeah. But how do you take the square of x?
you times it by x.
Good, excellent, right? So that's one way. You times it with x. So you times x with x using a dot steric multiply operator, right? So that's one possibility. The other one is what Hussein also said in the chat box, and Daniel also said in the chat box, which is just, or actually, wo bhi, that's your solutions are correct as well, by the way, Daniel and Hussein, your solutions are correct as well. This is another solution. You take x, which is a row vector, and you multiply with the transpose of it. So what happens? So that essentially is going to achieve exactly the same objective. Okay? So this is going to be x of 1 times x of 1 plus x of 2 times x of 2 plus x of 3 times x of 3, and so on and so forth. Okay? So and one of the things that now you should perhaps realize is that there's no one way of implementing it, right? So there's no one unique solution, as you may have learned in high school, right? High school may typically, from what we know, students are told, yeah, this solution is my way or highway, right? It's not really so. So there are many ways of solving this, and this is my take on it, right? So this is x multiplied by x transpose, but some x dot raised to power 2 is also good. Some x dot steric x is also good, Hania. Qasim says it's some x times some x. Right? इसके बारे में सोचेगा थोड़ा. Why, Qasim? This is not correct.
Wouldn't that be different though? Because because multiplying a sum by itself is not the same as adding the squares of a vector and summing them up.
Excellent, right? So Qasim, इसमें ये देखें. So I will give you a very simple example, which is, what is a plus b whole squared? Right? That is not equal to a squared plus b squared, is it?
A b square plus 2ab.
So there's another term here, right? Okay. So similarly, a plus b plus c whole squared is not equal to a squared plus b squared plus c squared. There are other terms involved, right? So आपका जो solution है, that would actually do what? That would be equivalent to, you sum everything and then take the whole squared outside. Okay, you get it? Is that clear?
Yes.
Good.
Yes.
Excellent. Okay. All right. And then I move on. Let's do this. How would you write this in MATLAB? I will not pick on you, Qasim. Okay. So let me pick somebody else. Vaji. Right, Vaji, are you there? Isra?
Yes, sir.
Right. So what do you think the answer should be?
So it should be SE is equals to
Yeah.
x. So I'm not sure, but we'll minus both, matlab, minus both of these x in bracket n minus y bracket n, and then SQRT square कर देंगे उसका sum
Right. So
of both of these.
okay. So SQRT, remember, is square root.
Oh yes, sorry sir. वो जो नहीं होता exponent 2, we'll do like that.
Yes, excellent. So that raised to power, right? So this is shift 6. Okay. Dot steric.
Yes.
Right. So right, and Daniel says some. So Daniel, okay. So last part was a mistake. That's fine. Excellent. Right. So that's the solution is correct as well. And similarly, you could have many other solutions as well, right? What I have is just going to follow what the solution up here was, right? Which is x minus y times x minus y dot or transpose. Okay? So once again, you have x minus y, which is a row vector, and x minus y transpose. That is another row vector, but so transpose is a column vector, and just multiplying the row vector with a column vector, essentially what would that achieve would be that each and every one of the elements is multiplied with each other, and then you're summing all of them up. Okay? So that's another. So, and there could be other ways of doing it, as I can see in the chat box as well. Okay. So Daniel, you have the correct solution as well. What about this? Okay, Hussein, can you unmute yourself and ask it out loud?
सर उसके अंदर n is equal to 1 से लेकर l तक सम हो रहा है.
Sum. All right. So sum जो है कहाँ पे implement? So I say there's a vector which contains the elements 1 and 2. ठीक है? दो
Yes,
elements
sir.
का vector है.
Yes, sir.
Right? There's an element 1 and there's an element 2. If I take the row vector 1 and 2 and multiply it by the column vector 1 and 2, तो क्या result
Yes,
आएगा?
sir. सर उसका स्क्वायर हो जाएगा.
जी?
सर स्क्वायर हो जाएगा.
स्क्वायर हो जाएगा, लेकिन 1 मल्टीप्लाइड बाय 1 होगा प्लस 2 टाइम्स 2 हो जाएगा.
अच्छा अच्छा अच्छा, मैट्रिक्स मल्टीप्लिकेशन.
Matrix multiplication, excellent, right? So it's matrix multiplication. That's what's happening. Ji Iman, go ahead.
I just wanted to ask that had our limit not been from 1 to L, and
Yeah.
rather than L it was something shorter, that we
Yes.
didn't want the sum of the entire vector, then we'll have to use the for loop, no?
So you can still use, so excellent, Iman, that's an excellent question. You will still be able to use the matrix handling capabilities of MATLAB as, yes, last example में आप देखेंगे, right? So in that case, I would rather have this. So perhaps from the next time around, I should have a tablet here as well. I'll try to do that next time. So you would have the indexing operation here. Okay? So let me go to the last example and I'm going to come back to Iman. Okay? All right. So what about this? So let me ask you, Iman, आपसे पूछता हूं मैं. So this is a summation, x of n, y of n, and then you're adding all of them up.
We're multiplying the values of x. So
Yeah.
can we do x dot steric y and
Yeah.
then this that?
And then you sum that. Okay, that's one way to do it. And that's perfectly fine. That's
with the multiple.
Yeah.
Or
So
the way you've done it, will that x multiplied by the inverse of y, the
yes, excellent. So that's not in the inverse of y, perhaps you meant the transpose of y.
the transpose of y.
Okay, excellent. So excellent, Iman. So those are, both of them are actually valid solutions, right? And either way, you should be okay. So Mukim actually writes out, and that's a valid solution. Okay, and x times y transpose is also a valid solution. You'll get exactly the same results using both expressions. Okay, so I have this here, x times. So actually, there's a typo here. This is x multiplied by. So there's a static here. I'll correct this and upload them when I upload the slides. Okay, so this is x static y dash. All right, and finally, to answer your question, Iman, this is now slightly more involved, right? Where what I'm saying is, okay, I am not necessarily summing over all of the indices. Okay, I am not necessarily summing over all of the indices. Shazir, yes, loop is one way to do it. You can do this without a loop. And the code that you see here is actually without a loop. Okay, so let me make this correction here quickly so that you don't get confused. So this is, all right. Right, so here's a correction. Right, so now you get it. So Iman, so right, so this is x of n, and right, so there's a, sorry, let me, here you go. Okay. Okay. So now this implements the summation. Okay. And Salman, yes, you're exactly right, and I've made that correction. Thank you for pointing this out. Okay. So you're messaging in private. All right. So you see, you could use for loops for this, right? But what I have rather done is I've defined now two modified arrays. So there's a array X, which consists of all of the elements of the original vector X starting from index 4 all the way up to index L. ठीक है? और जो y vector है वो that starts from 5 and all the way up to L plus 1, and that ensures that the lengths of the two vectors are exactly the same, so that can be matrix multiplied. So if I can multiply the row vector with the column vector, and this would ultimately achieve this result, right? And yes, Firas, excellent, that also would work. So Firas has another solution in the chat box. I would urge you to take a look there. That would also work. So if you're more comfortable with that, that's fine. I myself am more comfortable with this. Why? Because this doesn't involve too much built-in functions. I don't have to use the sum command, but rather matrix multiplication. But if you're comfortable with the sum command, that's perfectly fine. That would also work. Okay? All right. Any questions here before I move on? So this was perhaps an overview of signals and signals operations in MATLAB.
Yes, sir, I have a question.
Ji Vikas, go ahead.
Can you please tell why are we using this transpose operator here? I don't get it.
So transpose, so you see vector multiplication किसमें होती है? Right? So vector multiplication may, if you have a row vector, right, which has elements 1 and 2, you multiply that with another column vector which has elements 3 and 4.
Okay, okay.
तो क्या होगा?
Yes, sir. क्योंकि उसका जो first के column होने चाहिए और second के rows हैं वही.
Excellent, right? So you're going to be multiplying the first element of the row vector with the first element of the column vector plus the second element of the row vector multiplied with the second element of the column vector. Okay? So this is exactly why I'm using the transpose, right? G Qasim, go ahead.
Sir, question.
Right. So Qasim has raised his hand. If you have a question, please raise your hand. Qasim, go ahead.
Sir, just like we were talking about the loops, that we can also do this stuff, the MATLAB script using loops. So I'm very poor at loops. Rather, I don't know anything about loops.
So that's fine. Don't use them then. So you can do without the loops. You can do without the loops.
Free throughout the course to use them. So
you may be required to use the loops very, very seldom, right? So, and if there's something that you're going to use, I mean, as in this lab, I've given you sample code for that, for those loops. Okay. And you can build on top of that, and we'll help you.
Thank you, sir.
Right? Acha, Jazlan, go ahead.
सर ये जो लास्ट वाला पार्ट है इसमें सिर्फ एक कंफ्यूजन है कि इट्स समेशन ऑफ x टाइम्स x ऑफ n मल्टीप्लाइड बाय y टाइम्स y ऑफ n प्लस 1.
यस.
तो जब आपने राइट साइड पे जो फॉर्मूला लिखा है इसमें समेशन कैसे हो रही है? दैट्स जस्ट माय ओनली क्वेश्चन.
तो उसमें समेशन इस तरह हो रही है कि दिस इज x ऑफ 4 मल्टीप्लाइड बाय y ऑफ 5. ठीक है, प्लस
x ऑफ 4 कोलन l, इसका मतलब है 4 से लेके l तक जितनी भी इसकी रोज हैं वो
नहीं, जितने भी कॉलम्स हैं उसको जमा कर लो, जो जितने भी एलिमेंट्स उसका जमा कर लो 4 से l तक.
ओके, सही है.
ठीक है.
एंड देन y के अंदर 5 से l तक, 5 से l प्लस 1 तक,
l प्लस 1 तक. एग्जैक्टली.
सिर्फ y में हमने 5 की किया. दैट्स कंफ्यूजन सिर्फ यहीं पे हो रही है मुझे.
दैट्स बिकॉज़ ऑफ दिस प्लस 1 हियर.
Okay, I get it.
That's an excellent point. That's an excellent point. Maybe I should have emphasized this more. This starts from 5 because this is a plus 1 here. ठीक है? So when n equals 4, x of 4 यहाँ पे y of 5 बनता है. X of 5 यहाँ पे y of 6 बनता है. So there's an offset by one sample. ठीक है? Jazlan?
That answers my question, sir. Thank you.
And I think Haris had a question.
Yeah, it was the same question as Jazlan's. Thank you.
Okay. Is that answered now?
Yeah, thank you.
Okay, all right. So this is just.
Sir, I have another question.
Yes, please go ahead, Waqas.
Sir, ये MATLAB script जो third वाले क्या है?
जी.
नहीं समझ आ रही. Sir, x minus y तो हमने कर दिया, लेकिन but we are again taking the square. हमने multiply करवाना ना, तो इसके अंदर वो वाली command नहीं use हो सकती जिस तरह x dot cap square.
हो सकता है वो आप अगर साइड पर देखें. That was one solution proposed by one of the students, and that's correct.
Okay.
All right. Achari, so let's go ahead. And now, so given all of that review, let's try to dig deeper. कि ये correlation है क्या, right? So if I ask you to, so if I give you these two signals, ठीक है? So let's say ये gunshot की template दे दी मैंने आपको, ठीक है? So I would expect the gunshot to look something like this. But then I make a recording, and this is an actual audio clip, by the way. I make a recording and I find that the recording that I get is something close to this, right? And I need to somehow match this template with this test signal, right? So exactly, Shazad, that's because of background noise. So I need to somehow match this signal with this signal. Can you try to develop your own matrix? ठीक है, देखें चीजें बहुत सारी एग्जिस्ट करती हैं, लेकिन let's try to build up something on our own, right? So let's say if I were to ask you to devise your own solution or your own quantitative metric which tries to capture the similarity, what would you do? Right? So Hussein says, why don't we try a difference, right? So Ji Jazlan, go ahead.
सर अगर हम इसमें मतलब पैटर्न चेक करें इसका,
Yeah.
तो इज इट सेफ टू अज्यूम कि जो एरे सिग्नल एरे इंडेक्स जो है वो ऑलमोस्ट सिमिलर होगा फॉर लाइक ऑल गन शॉट्स या समथिंग, या फॉर द डेटा दैट वी हैव?
Okay, good. So excellent. So पहली बात ये है कि the two signals that I've given you, they are exactly the same length. So this is an assumption that I'm working at the moment. Okay, they're exactly of the same lengths, right? And then the question is कि if you're given a template, right, और actual gunshot fire होती है, तो वो actual recording क्या gunshot की template के बराबर आएगी या नहीं आएगी? So Jazlan?
सर मतलब टेम्पलेट के बराबर तो मतलब बहुत ही इम्पॉसिबल है उसका आना।
Excellent.
बिकॉज जिस तरह हमने लैब 4 में जिस तरह किया था कि व्हेन वी अप्लाइड द फिल्टर फ्रॉम 0.1 हर्ट्ज टू 1 हर्ट्ज, तो क्या था कि बहुत सारी जो बैकग्राउंड नॉइज थी या जो क्या ना सॉर्ट ऑफ लाइक जीरो एरर सिग्नल्स जो थे उसके, वो रिमूव हो गए थे।
Yes.
तो हमें इसमें भी कुछ ऐसी सिमिलर ही चीज करनी पड़ेगी ताकि जो है ना मतलब हमारे पास एक स्मूथ साइनसॉइडल वेव आ जाए।
All right. So my question then would be, and that's an excellent point, even when you get a smooth signal, right? Let's say let's assume for now that this is the smoothest signal that I could have ever achieved, right? I would need to somehow match this at some point, right? Right?
सर फिर उसमें आप ये एरे इंडेक्स यूज कर सकते हैं ना, लाइक आप ये देख लें कि आपका जो जो लेट्स से टेम्पलेट है वो किस इंडेक्स से स्टार्ट हो रहा है,
Yeah.
और आप अपने जो एक्चुअल टेस्ट सिग्नल है उसको उधर उस पॉइंट से देखना वो एनालाइज करना शुरू कर लें।
हाँ, तो
विल
analyze
अज्यूम
का
कि
क्या
लेट
मतलब है?
से मतलब लेट्स से कि वी से कि हमारा जो एरे इंडेक्स है वो लेट्स से 130 पे या 140 पे हमारा गनशॉट स्टार्ट होता है।
Yeah.
So what we'll do is we'll start measuring in the test signal, हम वहाँ से अपना सिग्नल देखेंगे कि 140th इंडेक्स पे स्टार्ट हो रहा है,
Yeah.
तो उसके बाद डाटा की क्या प्रोग्रेशन है।
Right, exactly. So आप data की progression देखेंगे, so you have to have some sort of analysis. You have to have some sort of comparison of the recording with the template, right? And as one of the students mentioned, I forget the name of the student. He mentioned this error as a potential metric that can quantify the similarity. ठीक है, मैं क्या करता हूँ कि मैं एक एक सैंपल लेता हूँ टेम्पलेट का और टेस्ट सिग्नल का, and I compute the difference, and I'll get a difference vector, and I sum all of the difference elements. ठीक है, is that a good idea or is that a bad idea? So I claim that that's not a very good idea. Why? And there's this may be a little subtle. Like let's see, somebody can.
Sir, may I speak?
Yes, Jazlan, sorry, if you allow me, can I have other people speak as well? So Umar Ramzan.
Sure, sir.
My apologies, Jazlan, so I'll get back to you later, right? Excellent. So at least I'm getting some correct answers in the chat window. I do want to mention here, KR, chat window is fine. That gives me a very, very nice picture of what's going on. I would rather hear from the people and perhaps see their faces as well if I can, right? I don't know who I'm talking to. So Omar Ramzan, if you can unmute yourself and tell me what you meant by that. They'd cancel each other.
Yeah, the negative differences would cancel out with the positive differences, and you might be left with the zero when there's a lot of difference.
Excellent, excellent. So that here's the problem. The problem is that you can come up with for some cases where the difference was large, right? So the template was nowhere near to what the test signal was, but some of the elements in the difference were very, very big, and there were some of the elements in the template were very, very small in the negative and the positive. And when you add them up, the negatives can add up with the positives and they cancel each other. And the resultant signal that you make, the resultant error that you may get may be zero, despite the fact that they do not look alike. Okay? Despite the fact that they are not the same. So therefore, this error is not the right solution, right? And one of the right solution, as somebody mentioned here, is the absolute, right? So I forget, यहाँ पे ऊपर comments में था कहीं कि why don't we take the absolute error, right? So for each one of these indices, I take the error, I take the absolute. तो अगर positive है तो positive ही रहेगा, negative है तभी positive हो जाएगा, and then I keep up adding them up. So I would make sure that what I actually capture is the true absolute essence of what the difference was. Okay? So that's one, and that's called the absolute error, and that's a valid metric. Another metric, as somebody else pointed out, is the squared error. And I think we did this in one of the labs as well, the squared error or the squared energy, at least. Okay? And this more or less does the same exactly. वो क्या करता है कि जो positive है वो positive ही रहती हैं, negative values हैं, they're squared and they become positive as well, and you add them up and you would still be able to get rid of the problems where the positives add up to the negatives to cancel them out, right? So the squared error is a good metric, and the absolute error is a good metric to capture the similarities. ठीक है जी अब्दुल्ला, go ahead.
जी सर, मेरा एक सवाल है सर, ये है कि जो अभी एरर्स जितना डिफरेंसेस हैं हमारे सिग्नल के एम्पलीट्यूड्स में, हम उनको ऐड अप कर रहे हैं, उनके एब्सोल्यूट वैल्यू ले रहे हैं, यहाँ पे स्क्वायर ले लें सर, लेकिन ये स्केलिंग के लिहाज से सर लेकिन स्केल्ड नहीं है, एज इन अगर हमारा बड़ा सिग्नल हो और लेकिन उनमें डिफरेंसेस छोटे छोटे हों, लेकिन जब उनको ऐड अप करें अगर हम, तो हो सकता है वो डिफरेंस की एज सच वैल्यू काफ़ी ज़्यादा हो एज़ कम्पेयर टू एक छोटा सिग्नल हो लेकिन उसमें डिफरेंसेस बहुत ज़्यादा हों.
Excellent.
तो वो इक्वेट कर देगा कि वो दोनों के ऐसे लगेगा तो ऐसे ही कि दोनों में एक जितना ही डिफरेंस है.
So Abdullah, you've actually touched upon a very, very deep point, which I do not want to go into this lab. Okay, so I can have a conversation with you afterwards. And what the concern that you mentioned is indeed a valid, very, very valid concern, and there are ways of going about it, and there are other metrics that we use typically. As far as we're concerned, as far as the champions of EE100 are concerned, we will stick with these and not worry about the concern that you raised too much. Okay? I can talk to you afterwards. Okay, Abdullah? Right. So the squared error is a good metric. Absolute error is a good metric. Or squared error, let's focus on that. What do you expect? If the similarity goes up, you would obviously expect the squared error to go down, right? And that makes sense. Okay? If they're exactly the same, the squared error would be zero. And I can actually claim that the squared error will be zero if and only if they're exactly the same. Okay? If and only if. The only way that the squared error could be zero is if the gunshot template and the test signal are exactly the same. There's no difference whatsoever, right? That is when the squared error will be zero. Only then the squared error will be zero. Okay? So this is a squared error. And if I just sort of expand this a little bit through the expansion of the summation, let's not focus too much on that. It turns out that the squared error is equal to this. There's a constant term and plus another constant term and minus 2 times this term. Right? And this is a term that we're going to keep on focusing from here on. And this term is called the correlation, right? And I'll have something to say more about this. Daniel, do you have a question?
Yes, sir. So you just said that if there would be differences between the signals, the squared error would not be zero. I would like to ask that, would the case be still happening if there would be absolute error?
Yes.
Like, would absolute error be also not zero if they're not similar?
Bilkul. But not, so what you're saying is correct. So for absolute error as well, the absolute error is going to be zero if and only if the signals are exactly the same. Okay? I cannot say the same about the regular difference though. Get it, Daniel?
Yes, sir.
Absolute regular error zero hai, so that does not necessarily mean that they're exactly the same. And that's why that's not a good measure.
All right.
Okay? Ji Basit, go ahead.
Sir?
Yeah.
Sir, why did we write EX in place of sum of x square and ET in place of sum of t square?
All right. So this is just a simple algebra. I don't want to focus too much on that. That maybe is from your maths courses. So this is just x squared plus t. So x minus a minus b whole squared को मैंने expand किया.
No, sir. In the last line, you wrote EX plus ET.
Yeah. So okay. So I'm just saying कि ये जो पहली term है ना, let me call that EX, and the second term, let me call this ET. And that's the notation that I'm using. Okay, so this is actually the energy in x and t, and which we're not concerned too much, right? I'm concerned about this something called the correlation. Let's just focus on that, right? Aisha, go ahead.
Sir, my question is, even if hum square ले रहे हैं, we're taking the square after we are subtracting tn from xn, right? So वो zero फिर भी आ सकता.
No. So Aisha, we're not taking the square after we're subtracting. We're taking the square before we're adding.
Oh, so we're gonna take the square and then subtract.
Exactly. So then add. So you take the square first and then add. That's what this represents. Okay. So from here on, we're going to be dealing with something called the correlation, which is this expression here. Okay. And I would expect that because of this negative sign, what would you expect? अगर squared error कम होता है तो ये correlation क्या होना चाहिए? ज़्यादा होना चाहिए, कम होना चाहिए? ज़्यादा होना चाहिए, right? Why? Because of the negative sign, right? So, right. So this is the overall picture here. Okay, similarity goes up, the squared error goes down, and because of this negative sign, you would expect the correlation to go up, right? And that's the motivation of what correlation represents, right? So Shazir, the reason why it would increase is because if this goes low, right? Why would it go low? Because there is a negative sign here. So this must go up for squared error to go down because of this negative sign. Okay, Shazir?
Okay, sir. Thanks.
Right. So here's the final summary. Okay. पीछे वाली सारी कहानी थी एक was basically a motivation of why what we're using. This is called a correlation matrix, right? Which is used so often in engineering applications, in signal processing applications, and is defined as this sum, right? Which is कि अगर मैं आपको दो signals दे दूं या दो vectors दे दूं, उनकी correlation क्या होगी? Is element by element multiplication and you add them up. ठीक है? And if it's element by element multiplication, you add them up, and once you get a result, you say कि similarity जो है, if you have a very highly similar signal, the correlation is going to be high as well, right? So that's something to remember, if you will, right? I wouldn't go as far as saying इसको रटा लगा ले, right? That's not what we're here for, right? But if you were to remember one fact based on all of the reasonings that we've done there, okay? The similarity going up means the correlation going up. If similarity going down means the correlation going down, okay? And where did the 2 go? 2 does not really make a difference. Like किसी चीज को मैं 2 से multiply कर दूं, divide कर दूं, it's just an scalar multiple. I don't care about it too much. ठीक है, but that's a good point. Ahmed, go ahead, please.
So what will be the correlation in the case that they are exactly similar?
All right. So I don't want to, that's an excellent question as well. If they're exactly similar, it turns out कि जी वो उनकी energies के साथ आपको कुछ deal करना. So it's going to reach a maximum, some maximum level when they're exactly similar. ठीक है? So what is that maximum level? That has to deal with how strong those signals are.
So if it's 2,000 or 10,000, doesn't matter. And if it's more than the maximum, it's always it's 100% similar, right?
Yes. So if it reaches a certain maximum, I've not defined what the certain maximum is. That means they're exactly the similar.
Okay. So if the maximum is 1,000, suppose arbitrarily, and we get a value of 2,000 or 10,000, it is just as similar if it was 1,000, right?
Yeah. So it's you would work with the ratio there.
Okay.
ठीक है, आप कहेंगे यार maximum 10,000 पहुंचना था, ये 2,000 पहुंचा है, तो it's 0.2 or something. So I would say कि यार it's not very similar maybe. Right, and that's a judgment call. Okay, as we're going to see. Acha, I do want to motivate this another way as well. So high school mein, you would have learned something about called the dot product, right? And I'm sure you know what a dot product is, right? So Isha, Zohair, can you tell me what a dot product is between two vectors?
Not really sure about
Sure.
it.
Okay. So Aisha, can you tell me what a dot product between two vectors is?
It's the product of the magnitudes of the vectors into cos of the angle between.
Okay, excellent. So which is equivalent to something which looks similar to the expression that I'm showing you, right? एक मैं आपको वेक्टर दे दूं 2-dimensional space में, यूक्लिडियन स्पेस में, उसका एक x कोऑर्डिनेट है, एक y कोऑर्डिनेट है, राइट? एक और वेक्टर है, उसका भी एक x कोऑर्डिनेट है, y कोऑर्डिनेट है. इन दोनों का जो डॉट वेक्टर होता है, डॉट प्रोडक्ट होता है, वो क्या होता है? वो the x coordinate of the first multiplied by the x coordinate of the second. जी Hania, go ahead. I'm sorry,
No,
are you Hania or Hania?
Hania.
Hania, okay. Please go ahead.
No, I was just going to say the same thing that you just said.
Okay.
You
for my own benefit, please go ahead and say it again.
You multiply the x of the vectors and add them with the y of
Good.
both.
Excellent. Right. So you take the x of the first multiplied by the x of the second plus the y of the first multiplied by the y of the second. Right. So that's a dot product, right? So अगर मैं आपको एक वेक्टर दे दूं x जिसमें दो elements हैं, तो what you see here, this correlation is nothing but the dot product. Right? If I gave you a vector where L was equal to 2, okay, and X was a vector and T was a vector in a two-dimensional space, right? This would entail a dot product, right? Just like you have a dot product in a Euclidean space. वो dot product कब maximum होता है? Ahmed, Shumail, वो dot product, do you remember when is the dot product maximum?
When they are perpendicular?
No, तब minimum होता है, वो vector product maximum होता है.
Sorry, when they are parallel.
When they are parallel, when they're aligned, right? When they're aligned, they're similarly aligned. That's when their dot product is the maximum. And why? Because Aisha said as well, okay, this is the magnitude of the first multiplied by the magnitude of the second multiplied by cosine theta. And cosine theta, of course, can never be greater than 1. The maximum value is theta equals 0 पे आता है, ठीक है? So and the maximum value, Ahmed, this also gives you dot product में maximum value क्या होती है? Is actually equal to the product of their magnitudes. That's the maximum value you can have in the dot product in Euclidean space. यहाँ पे भी इसी तरह की चीज है, right? It's equal to something called the magnitude of the vector, ठीक है? And let me not say more about this, right? So when the angle is 90 degrees, that's minimum, that dot product is 0. But the point I want to make here is just like in your Euclidean space, if you have a two-dimensional vector, you take the dot product between the two. That dot product is the maximum when they are similar, when they are similarly aligned, they're in the similar direction. Okay? And this is another way to think about this correlation. Actually, in correlation is actually a dot product. I mean, it's a dot product ki generalization from what you have studied. Okay? So you, as you're going to see, things are much deeper, and that's the fun in learning. Okay? So where does the angle come in this correlation? That's beyond the scope of this course, but there is I can define an angle at a scale which is beyond the scope of this course. Okay? I'm not going to talk about that. Hania, you have a question, or do you want to say something?
No, I have a question.
Yes, go ahead.
You said that this expression gives the dot product.
Yes.
I don't understand how.
You see, so this is, let's say capital L was equal to 2.
Yeah.
Okay? So what would you have? You would have had, this would be equal to x of 1 times t of 1 plus x of 2 times t of 2, right?
But isn't x and t the y and x?
No, that's not what I'm saying. Okay. So what I'm saying is that x is another vector, और उसका x coordinate x of 1 है और y coordinate x of 2 है.
Okay.
T is another coordinate, उसका x vector t of 1 है और उसका y coordinate t of 2 है.
Okay.
If that's the visualization you make, then it's actually x times x plus y times y.
All right.
Okay? All right. So the next question is, Ji Qasim, you have a question? All right. So the next problem, we should go back to the gunshot template matching problem. ठीक है? अब do you really expect कि आप जो है एक शहर में बैठे हैं, लम्स में बैठे हैं, you have a system there which is continuously recording data, audio clips record कर रहा है, ठीक है? And you actually have to find that gunshot template anywhere that could happen. I mean, you don't exactly know कब होना है, right? That's the entire point of the gunshot detection system anyway, right? So you would, in general, have a long sequence of a test signal, which is much longer than the gunshot template. ठीक है? So the correlation, अभी तक हमने जो बात की है वो क्या है? Correlation between vectors which have equal length. Now what do we do? If we have a long sequence of data, ठीक है? So this is a long sequence of data in which you have to find a short sequence of data. ठीक है? What do I do here? Can I devise a solution here? Right? Discard पहले वाला data. On what basis do you, Hussain, discard that data? Right? So you have to have some basis, right? And the पहले वाला data, I will use once again correlation to try to determine whether to discard that data or not to discard that data. ठीक है? And this is what I mean. So let's work with a very simple toy example, right? And this toy example is, let's say this is the template signal, right? So this template is 0 here, and 1 here, 1 here, 1 here, and then 0 here. So this is of length 5, right? This consists of 5 samples. The test signal is much longer, right? This is of length 12. Okay, now you need to find this template signal in this test signal. What do I do? One of the solutions I could employ is, okay, let me just place the test signal as it was, and then यहाँ पे template signal place किया, and let me compute the correlation of the blue signal with the red signals in which it overlaps. ठीक है? So essentially this is this red signal multiplied with this blue signal, the blue value, plus this multiplied by this, plus this multiplied by this, plus this multiplied by this, and so on and so forth. Okay? So this is going to give me a correlation. This is going to give me of correlation. Yes, LT is the length of the vector T, and LX is the length of the vector X. Okay? So this gives me the correlation that I compute when when the template is standing here. Okay? And this is the MATLAB code for this. So all of this information, this is available in the template in the lab handout. And yes, Aisha, this will turn out to be a low correlation, as you can see is 0.08. ठीक है? फिर मैं क्या करूं? Aisha, if you can guide me here. अब आगे क्या करूं?
Sir, then you can move the template by 1 forward, and then check it again, and then
right.
Keep doing
Excellent. So Shazir says the same. And this is what I do. I just move the template right by 1 sample and then compute the correlation again. So now this is this thing multiplied by this plus this thing multiplied by this, and so on and so forth. Okay? And the correlation that I get here, I mean, this is the summation. This is the MATLAB code for that. Okay? And you don't need to really write it. All of this is there in the handout. And this is the correlation that you get. Correlation is slightly higher. Okay? फिर आप क्या करते हैं? फिर एक और आगे shift कर देते हैं. And the correlation is even slightly higher. Then you slide it again, and the correlation is 1.88, right? And then you slide it again, and here the correlation turns out to be 2.88. And this is where these 3 peaks reside on the 3 peaks of the template of the test signal. Okay? And then you keep on sliding it. You keep on sliding it, right? And this is where you end, where the last element of the blue vector coincides with the last element of the red vector. Okay? And this is a correlation matrix that you get, or correlation vector that you get. Okay? So the first time instance 0.08 था, फिर 0.23 था, फिर 1.25 था, फिर 1.8 था, फिर 2.88 था. ठीक है? अब 2.8, what I do is I pick up which the maximum, the highest correlation कहाँ पे आई और कितनी आई, right? As Qasim says as well. So I'll pick up what the maximum correlation is, which is 2.88, right? And then the decision I make, decision कैसा लूँ? All the decision I'm going to make is I'm going to say, yeah, let me have a predefined threshold, and say, okay, as if the maximum value of this correlation is above a certain threshold, my system is going to decide that this was a gunshot. And if it's below a certain value, my decision is going to be it's not a gunshot. Okay? That's a potential decision that your system can make, which, believe it or not, as simple as it is widely used. And we've published papers on this. Okay, where we use this correlation and try to figure out कि performance कैसी आती है with our actual database. Okay, so all right, so Hussain, I may not answer this. There are ways around that as well, by the way. Okay, so you pick up the maximum correlation and you try to see कि वो threshold से ज़्यादा है नहीं. This is the MATLAB code for this. I'll skip over this. This is there actually in the handout. I'll upload the slides as well. So this is essentially what you're looking for. If I can also show you a MATLAB demo. Okay. Right, so here you go. So this is actually with actual gunshots. Right, so what you see here is, can you see the MATLAB screen, the window?
Yes, sir.
Yes, sir. Okay. Right, so you see this is the template, the green template. The green signal is actually the template that I showed you. This is that exact template, and this is based on recordings we made ourselves. Okay. This blue signal that you see is my test recording, and this once again is from our own recording. And then what we do is we do correlation. So we compute the correlation here, okay, and then we start moving the template. So my MATLAB is okay. So you start moving the template to the right, and you keep on computing the correlation. And you see the correlation stays quite low as you're sliding over the signal in which you did not have a gunshot and there was silence. Okay, it stays low, stays low, stays low, stays low, stays low, and as you inch towards the actual where the gunshot was, you see the correlation starts rising, right? And this is where it's exactly on the top. This is where the correlation turns out to be the maximum. And this is an indication also of where the gunshot signal was. And as you keep on moving, this is going to go down again. Okay? And you can go on. And the final correlation curve that you're going to see at the end of the day, the computation, is going to be this blue signal that you see. Okay? And mind you, this demo, and I can have an animation going on here, is done with MATLAB. So this is something we wrote ourselves. Okay, so let me go back. And so this is going to be one of the lab tasks, right? Okay. Right, so all right. So you compute the maximum correlation with the threshold, and if it's above a certain threshold, you say it's a gunshot, otherwise it's not. Okay? Acha. Let's go back to this localization principle. So that's the second task. You only have 2 tasks in the lab. Okay. So आपको आवाज किस तरह आती है? अभी आप आंखें बंद करें, right? And can you tell where the sound came from? Of course you can. Yes. Mammals can do that, right? Ever wondered why?
So because of so can I speak?
Yeah, sure. Go ahead. Go ahead, Qasim.
So there's a theory of which is like Doppler's effect. Because of that, you can like judge where the voice is coming on and whether it's in frequency.
So Qasim, that's not because of Doppler effect. Doppler effect ये होता है कि अगर कुछ चीज move कर रही है तो frequency change होती है, right? So over here it's because you have not ear vibrations, but rather you have 2 ears. अल्लाह ने आपको 2 कान दिए हैं, तो उसकी और बहुत सारी वजूहात हैं, लेकिन एक वजह शायद जो है which the superpower that you have because of these 2 ears is because each one of the ears is actually receiving a different audio stream, right? So it's stereo, as Islan says, right? असल में आपकी जो brain है is actually perceiving stereo sound, right? You have a right audio signal and you have a left audio signal. And if somebody is speaking from over there, right, that signal reaches this ear earlier than it does theirs. Okay, so as you can see in this example here as well, the time it takes for the sound waves to reach this ear is going to be smaller than the time it takes to reach this ear. Okay, and so there's going to be a difference in there, right? If there is a difference in there, your brain actually processes that and processes that delay to be able to actually determine, yaar, ye idhar se awaaz aayi thi, idhar se awaaz aayi thi. And that's exactly the same principle that we use for gunshot detections or localization. And we built this. So we've had undergraduate students build this for semester projects, by the way, as well. Okay. So it works with microphone arrays. You have a left microphone, you have a right microphone, you have two microphones. And if this is fired from here, we work with something called the far field assumption. जिसकी वजह से we say that the distance to the microphone array is quite large compared to the inter-mic distance, because of which these lines almost become parallel. Okay? And it's called the far field assumption. You can use geometry to verify this. I don't want to go into a lot of details there. And it turns out you do some more geometry and you find out कि यार ये जो अगर ये angle theta था ना, ये distance है d cos theta, and this d cos theta is the extra distance that the sound wave has to travel to reach this microphone, right? And from there, you know what this should be. So delta t is, or the difference between the right audio signal and the left audio signal is just d cosine theta divided by speed of sound. Okay, because it travels at the speed of sound, right? So what we can do therefore is, okay, right, so you given the right signal and the left audio signal, you just estimate what delta t is. Okay, delta t aa gaya, you know what the speed of sound is, you know what the microphone distance is, and you just compute theta. Simple as that, right? So once again, you compute what the difference between delay between this stream and this stream is, you multiply it by the speed of sound, you divide that by the inter-mic distance, and that gives you, take the cosine inverse, that gives you theta. Okay? So this is how we work with localization, right? So this is how we do localization. Okay? And this is how do we compute correlation or delay estimation through correlation. The idea is very, very similar to what we've done before. Let's say this is the left microphone signal, this is the right microphone signal. मैं right microphone signal को slide करना शुरू करूँगा, ठीक है? और मैं देखता हूँ slide करते करते, then I compute कि कहाँ पे correlation maximum आई. I see correlation यहाँ पे maximum आई थी, right? That means the correlation was maximum for a delay of 2 samples, right? And that means one of them was a delayed version of the other by 2 samples, and therefore this gives me, and all of these details are there in the handout. The dt is 2 upon fs, where fs is sampling frequency. This is 45.3 microseconds, and this gives you theta, which is of 81.3 degrees. Okay, so all of this information is there in the handout, and these calculations are really, really simple. It's just based on some high school algebra. Okay, so high school mathematics. Ji Humaira, go ahead. Humaira. So, okay. So, Humaira, you want to speak up? Go ahead. Otherwise, I'm going to move.
Oh yeah, sorry, I forgot my mic. The thing is, I'm asking कि 3.15 का जो हमें पता चला है कि यहाँ पे कोरिलेशन मैक्सिमम है, आपने बोला कि 2 से डिले है, तो ये क्या?
Yeah, you see, so this corresponds to the correlation that I computed when I did not delay the left signal and the right signal. They were exactly in line. ठीक है? फिर मैंने right signal को एक sample से delay किया, and I compute the correlation that turned out to be 2.0. ठीक है? Then I delayed it yet again, and by 2 samples, and the correlation I got was 3.15. And then I delayed by 3 samples, and the correlation I got was 1.98. Then I delayed by 4 samples, and the correlation I got was 1.427. And I see that the maximum was 3.15. The maximum correlation was 3.15. So the match that I have between the 2 signals is when the right microphone is delayed by 2 samples.
Right, I get it.
Okay? So therefore, the delay is 2.2 samples, and in seconds, it corresponds to 45.3 microseconds. And therefore, this is the theta, which is just simple based on the formula. 333 is speed of sound. Yes, so it's 333 meters per second is the room temperature of sound. Okay, it does change with temperature, by the way. Okay.
So can I ask the question?
Yes, go ahead, Bakas.
So can you please tell why did we divide 2 by fs to calculate dt?
You see, this goes back to lab number 2, in which I said that these signals are continuous time and they are sampled at a certain sampling frequency. ठीक है? तो दो samples आपस में उनका कितना distance है in time in seconds? That's 1 upon the sampling frequency, right?
Yes, which is called time period.
Which is called the time period. Excellent. ठीक है? तो अगर दो samples हैं, दो samples का delay है, तो वो seconds में कितना correspond करेगा? That would be 2 times the time period, right?
Okay.
And the time period is 1 upon fs. Get it?
Thank you.
ठीक है, Bakas? Okay, thank you. All right, so this is the MATLAB code. This once again is there. So we've given you all of the benchmark codes. The template codes are there in the handout. They're here in the slides as well. All you need to do is to build on top of it. Okay. So these are the lab tasks. There are just 2 lab tasks here, right? So there are only 2 lab tasks in this lab. Task 1 is for you to implement a basic gunshot detection framework. And you have to test it using acoustic database. And the database is provided to you on MATLAB or on LMS. So if you go through the handout lists all of the details कि कौन सी file में क्या कुछ पड़ा हुआ है, right? So essentially that contains a gunshot database that we have recorded ourselves. Our students have recorded ourselves at an outdoor firing range in Lahore. And then it also consists of some audio clips which are not gunshots, but they are impulsive events. तालियां शामिल हैं उसके अंदर, right? उसके अंदर firecrackers शामिल हैं, राइट उनके अंदर जो है वो कार्स की कुछ साउंड शामिल है, कुछ साइलेंसर की जो ठा होती है, राइट, मोटरसाइकिल्स में, राइट, एंड ऑल ऑफ दोस आर कॉल्ड आउटसाइडर सिग्नल्स, राइट, एंड यू वुड हैव टू रन दिस कोरिलेशन सॉर्ट ऑफ मेथड टू फाइंड आउट कि यार मेरा सिस्टम कितना एक्यूरेटली गनशॉट्स को करेक्टली आइडेंटिफाई करता है, या फिर जो गनशॉट्स नहीं है उसको गनशॉट तो नहीं कह देता, राइट. सो यू नीड टू आइडेंटिफाई कि फॉल्स अलार्म्स कितने होते हैं और true detections कितने होते हैं for the algorithm that you're going to be implementing, right? So just you should have a sense of achievement in what you're going to be able to achieve at the end of the lab, right? You're actually going to be implementing an acoustic gunshot detection algorithm on your own. ठीक है जी, Shazad, go ahead.
Sir, the way we will differentiate between clap and gunshot amplitude के जरिए ना, क्योंकि सर लेकिन लेट्स से वी आर अज्यूमिंग कि वहाँ पर क्लैप्स के और गन शॉट के एम्पलीट्यूड्स डिफरेंट है, लेकिन लेट्स से अगर दोनों के एम्पलीट्यूड्स हमें डेल्टा में सेम मिल रहे हैं, तो आवर सिस्टम वोंट वर्क फॉर एनी ऑफ दिस प्रोग्रामिंग कोड, राइट?
So we ensure that all of the amplitudes are same, right? So we've done that normalization for you.
Okay sir, thanks.
ठीक है. So otherwise जो है वो we don't want you to do that. We've made things very very simple. ठीक है. जो टास्क 2 है उसमें देयर ओनली 3 डेटा, 3 आपको डेटा मिलेंगे, राइट माइक्रोफोन पे और लेफ्ट माइक्रोफोन्स के ऑफ एक्चुअल गनशॉट रिकॉर्डिंग्स, एंड यू आर गोना बी रिक्वायर्ड टू फाइंड कि यार ये गनशॉट असल में आई कहाँ से थी, किस एंगल से आई थी, राइट, फ्रॉम दोज रिकॉर्डिंग्स, एंड वंस अगेन कोरिलेशन इस्तेमाल करेंगे हम उसमें. ठीक है. Now we have instituted this bonus policy as well. So this is task 3, which is an optional task. You don't have to do it. This is not mandatory. This is completely optional. But for this task, you would have to estimate the average lag time from COVID-19 reporting to death. So the details are there in the handout. But essentially, this is the same as estimating the delays between 2 signals. I do want to say something about what the bonus policy here is. The details are there in the handout, but like very, very broadly, very, very roughly. What this means is that if you do attempt a bonus question here, you can use it to offset, or you can use it to replace any one of the regular tasks in the subsequent labs or the labs before this. ठीक है. अगर for some reason आपका grade किसी lab task में कम आया है, तो for any reason at all, you can use this bonus task if you've done it, and you can use as the grade that you get in the bonus task to replace the regular lab task in other labs. ठीक है. You can also use it. So you can also use it to decrease potentially your workload in the later part of the semester. So if you do this bonus task now, so it's like an immunity pin, yes, so if you do this bonus task now, you may very well decide in subsequent labs कि यार मैं फलां lab की एक task नहीं करूँगा and I'll have this bonus task to replace that task. But there's a limit to that. I mean, so the exact policy क्या है कि कितनी आप task replace करा सकते हैं, कितनी करा सकते हैं. All of those details are there in the lab handout. ठीक है? One of the other things I want to mention here is कि जो the lab handout is meant for you to go through. Some of the anecdotal evidence that we've received is that people would rather not read anything, but rather directly go to the lab tasks and start attempting it, and then say कि ये कुछ नहीं हो रहा मुझसे. So for instance, we know of people who did not bother to read कि there's a function available on LMS, and that needs to be downloaded and put in the current directory, and without even reading that, people started attempting the lab tasks. ठीक है? So it's important that you go ahead and read it first. ठीक है? That will go a long way in making sure that you're able to solve the problems efficiently. ठीक है? Without on your own, right? So the lab handout is designed for that purpose. So that it enables you to do it on your own. And on your own वाली चीज़ बड़ी ज़रूरी होती है. Okay? So I'm going to stop here and I can take questions. If there are no questions, you can start with the lab. So there are only 2 tasks and it shouldn't take you too long. Yes, Qasim, go ahead.
Sir, I want to say that just like you said कि हम ये कर सकते हैं on small scale आपने probably 2011 में किया भी था.
Yes.
Sir, do you this thing is feasible for countries, developing countries like Pakistan or India? ठीक है? जिसके अंदर आपको policing या फिर for your जितनी भी law enforcement agencies होती हैं उनके लिए utilize करना आसान होगा. In future अगर हम इसका कोई pilot project भी करते हैं within Lahore.
Okay. So for your information, Qasim, there is actually Safe City Authority का नाम सुना हुआ आपने, right?
Yes, sir.
So we know of our colleagues from another university who did a commercial project, and they've deployed some microphone arrays on Safe City poles. आप अगर कुछ सेफ सिटी के पोल्स देखें उनमें कुछ ना माइक्रोफोन एरेज लगे हैं, कुछ बॉक्सेस लगे हुए हैं. तो उनका पर्पस ये है, आई एम नॉट एग्जैक्टली श्योर दो कि वो कितने ऑपरेशनल हैं और कितनी इफेक्टिव हैं. बट यस, दिस कुड बी समथिंग व्हिच कुड बी एक्सट्रीमली यूजफुल.
For a city like Lahore, you need a lot of like those boxes.
Yeah, those boxes may not necessarily be very expensive. Okay, so the cameras that they're using right now, they're much more expensive than a simple microphone. वो आपको $1 $2 का मिल जाएगा, and some hardware to go along with it. That's not too expensive either. Okay,
Thank you, sir.
Right? Any other questions, concerns?